Alright, hi, my name's Hayden. I'm still unemployed, and this is day 15 of doing Leetcode until I get a job. This is Leetcode 3375, minimum operations to make array values equal to k. This is an easy problem, and it goes as so. You're given an integer array of nums and an integer k. An integer h is called valid if all values in the array that are strictly greater than h are identical. For example, if nums 10, 8, 10, 8 is a valid integer is h equals 9 because all the nums that are greater than 9 are 10, and 10 is and those are all identical values. 5 is not a valid integer because 10, 8, 10, 8 are all greater than 5, and they're not identical integer values. Okay, we're allowed to perform the following operation on nums. We're going to select an integer h that is valid for the current values in num, and then for each index I where nums I is greater than h, we're going to set nums I to h. Okay, and then we want to return the minimum number of operations required to make every element in nums equal to k. If it's impossible to make all elements in nums equal to k, return -1. Alright, this was very long-winded, but let's just go through an example. So for example, if with the nums array 52545, our first h that we're going to set is going to be 5. So we're going to say h equals 5. Or, sorry, we're going to set h equals 4. My bad. h equals 4. We're going to find all elements strictly greater in our nums array that are greater than 4. And that's going to be 5 and 5. So we're going to change these to our h, which is 4. Alright, cool. Now we're going to have to select a new h. This is going to be... I forgot to change one of the 5s. We're going to set this equal to 2 now. All the elements greater than 2 are 4, so we're going to erase all these. And we're going to make these all 2. Wow, 2 is now greater than, or 2 is equal to, k is equal to all the elements in our nums array. So this took 2 operations because we had an h of 4 and 2. So answer equals 2. Let's think about an answer where it's -1. So let's say we have k equals 1 and k equals 1, and let's say that we have, let's make this 2 actually, and we have 1, 5, 5. So with this one, the first k that we would have, or h, could be, let's say 2. So all elements strictly greater than 2 are 5, so we're going to replace our 5s with 2s. Now, if we make an h lower, like let's say we have h equals 1, all the elements in the nums array are going to become 1, which is less than what our k is. We want k to equal 2. So this is actually an impossible case. So first observation that we can make is if the minimum of the nums array is less than k, possible, return -1. Okay, that's our first observation. Let's jump into the meat of the algorithm. What's another observation? Our next observation is that we really only care about distinct integers in this situation. So we don't care really if we have a million 10s and a 1 or 1 10 and a 1. The next h that we're going to select is going to be 1. So we only care about distinct values. Right, 3. If we're to have a sorted array, so let's go back to our original example of, I believe this was 5, 4, 5, 2, 5. If we have this example, let's just erase everything here. We only care about the distinct variable value, so we're going to change this to 5, 4, 2. And we're going to iterate in the reverse of the sorted string, so this is by coincidence already sorted, cool, in descending order. At 5, we're going to want to make the h the next value down. So with the 5, we're going to want the next h to be 4. All right, cool. And then we're going to want the next h after that to be 2. So that'll change all these to 4, and then all the 4s to 2s. So our answer is really how long it takes to get to this 2 value. So the answer is really how many distinct elements are in our how many distinct elements are in our like sorted, or not even, we don't care about the sorted now because this is another simplification, is in our distinct integer set. And the number of operations required to reduce the set is now just going to be the number of distinct elements. All right, cool. So T, the number of distinct elements minus 1 is the answer. Okay, this is actually a really simple way to code this up, and I actually didn't figure out this solution before. So we're just going to do return len set nums minus 1. Oh. I made a mistake. Oh, my previous solution was required. Oh, because we have to account where... Okay. This simple little mistake. Alright, so return len set nums, and then we're going to do plus 1 if the min of nums, we're going to have min num if plus 1 if min num equals, does not equal k, else 0. Alright, now this should run properly. Oh, what am I doing wrong? Well, I thought I made a simplification. What's gone wrong? Where's this algorithm going wrong? Output 3. Hold on. If the min num doesn't equal k, we're gonna let's just go back to the drawing board here real quick. All right, if the min num, let's say, is 3, we're gonna have to do an operation to turn everything to 4, operation to turn everything to 3, and then operation to turn everything to 2. So that's the length plus 0. Okay, so 0 if min num doesn't equal k. Else, we're going to do plus 1. Is this correct? We want to make this minus, actually. So we subtract 0, so it's just going to be the length. Otherwise, this should be right. Okay. Let's submit this. All right, I'm just going to go over this quickly. So we're going to have two occurrences here. Let's have two examples, right? We have the example of this with k equals 2 and then k equals 1. With k equals 2, this is going to reduce into the set of 5, 4, 2. And our answer is going to be, so far, ans equals the length of this set, so 3. And then if we saw, we're going to subtract 0 if min num doesn't equal k. Does min num equal k? So 2, does it equal k? No, we're going to subtract 0, so minus 0. So the answer is to go from 5 to 4, 4 to 2, 2 to 1. All right. If k were 2 instead, if k were 2 instead, we would follow a slightly different procedure, and we would do 5 to 4, 5 to 2. As we see, min num does equal k, so we're going to add 1 to this. So if we go back, we're adding 1. So the length was 3. We're basically doing 3 minus 1 equals 2. So this is our answer. Oh, don't know what that is. T. And then this is if min num equals k. Wow, I cannot type. Subtract 1. Else do nothing. So that's basically what this is doing. I think I could write this more cleanly. We could do ops equals len set nums if k equals min num. We'll do if k equals min num. We're going to do ops minus equal 1. I think this is just generally a more clean way of writing this. All right, return ops. That should be the same. All right. This was Leetcode 3375, and let's see what our runtime was. All right, so our runtime, as we can see, we need to get a minimum element, and then we're going to create a set and find the length of that set. So really, this is just going to have an O of n because we need to get the minimum element, so we're going to iterate through the whole array as well as get the set. So time is automatically O of n. What about space? Space is only going to be O of d, where d is the distinct number of elements in this array, because we're only getting a set of all the distinct values. So space is O of d. And O of d is technically bounded by O of n also. So this is a linear time and space complexity, which is very good. And I hope that you enjoyed and that I was able to teach you something.